mini recap. What we learned from last week. Last week we learned one of the most important methods in this particular chapter, which is called oxidation number method. If you remember, guys, oxidation number method is the most powerful method because it can be used in every single situation. Unlike oxygen method and hydrogen method, which they have a lot of restriction. Okay, that oxygen method only can be used if and only if the question got oxygen. Hydrogen method can only use if you have hydrogen in your equation. Okay, but oxidation number method can be used in any single situation. It is one of the most powerful methods out there. So far, okay, make sure you must know. Alright, guys, if you remember what I told you last week I teach you two things. Number one, I teach you 4 rules. You can use 4 rules to determine or predict most of the oxidation number. Mark down my words, most, not all, okay? Some of the oxidation number you couldn't predict it. So if you have some unknown oxidation number, such as carbon dioxide, you don't know the oxidation number for the carbon. Let's say manganese, you don't know the oxidation number for the Mn. So if you have any unknown oxidation number, you use another thing called X method. Okay, you use the X method to calculate the unknown oxidation number. So far so good. Okay, alright. I give you a quick random example, 2 minutes, then we move on. Okay? Now I give you a random example. What do I mean? Let's say I have this question on the whiteboard. I have an ammonia. I have 2 ammonia reacting with 3 copper oxide. I am getting a nitrogen. I'm getting 3 water. I'm getting 3 copper, for example. Don't memorize, just a demonstration. Let's say, guys, I want and I force you all to use oxidation number method. Okay, let's say the question say, I want you all to use oxidation number method. You have no choice. You must use oxidation number method for this. How I do? Okay, first and foremost, we must able to list out all their oxidation number. Okay, how we list out oxidation number? You use the 2 things we learned from last week. Come on, everyone take part on this and go with me. First one, ammonia. Ammonia contain nitrogen. Do you know, do you heard, do you learn about oxidation number for nitrogen? No, you never, and you shouldn't know. Understand? So, if we have a nitrogen, whereby the oxidation number is unknown, what to do? Calculate it. So write it up. This is ammonia. The 2 in front don't bother. The number in front only for balancing purpose. Nitrogen, the oxidation number I don't know. Any unknown oxidation number, then it will be X. You add on with hydrogen. Hydrogen, how many P's you have? 3. What is oxidation number for hydrogen? Plus 1. So you add everything equal to total charge. Total charge is nothing, 0. So when you calculated X equal to -3. Yeah? By doing this, you already found the oxidation number for nitrogen. Are you that? So nitrogen is -3 here. Hydrogen always positive 1. Okay? Copper is Cu2 plus, so oxidation number plus 2. Oxygen, the oxidation number always -2. Okay? Oxygen always -2. Nitrogen is one species element. Element oxidation number 0. Hydrogen, the oxidation number always plus 1. Oxygen, the oxidation number is -2. Copper is one species element, oxidation number 0. All these things from last week. If you forgot, you can revise it. You can revise, you can refer back, it's okay. Alright. Now, after you list out the oxidation number correctly, the next thing is apple to apple comparison. You have to choose the right counterparts to compare. Let's say the first apple I choose is ammonia. So right hand side, I will choose who to compare against and to, understand? Because this fellow got nitrogen, this fellow got nitrogen, I think they can form a good pairing, right? From the left to the right, left hand side the nitrogen is -3, right hand side the nitrogen is 0. -3 to 0, I see the oxidation number going up. -2 to 0, oxidation number shoot up. When oxidation number shoot up, the ammonia is undergoing oxidation process. So when you undergo oxidation process, ammonia automatic will be reducing agent. Okay? So that is what you need to know. Second comparison is here. Copper oxide compared against copper. Why we don't compare against water? You don't see something in common, yeah? Because copper oxide and copper, at least you see something in common. You saw the copper. Okay, from the left to the right hand side, Left hand side, the copper, the oxidation number is +2. Right hand side, the copper is 0. +2 to 0, oxidation number going down. So when oxidation number going down, the process happening is reduction. Yeah? So the copper oxide is undergo reduction. When copper oxide undergo reduction, copper oxide automatically become oxidizing agent. So this is the main reason why we learned the oxidation number method last week. Okay with that? Okay? List out all the oxidation number, choose the right apple to compare, you'll be fine. Most of the student, the problem is not with comparison. Most of the student, the problem is listing out the right number. Okay with that? So once you're able to write all these numbers perfectly, you shouldn't have a big problem to do the subsequent analysis. So far so good? Okay? So oxidation number is the most important method you learned so far, because up to this moment I taught you 3 methods: oxygen method, hydrogen method, and oxidation number method. So oxidation number method is the most powerful method so far. Okay? Right guys, I make it clear. For me, I will do this. If the question asks me to do apple to apple comparison, and if the question never highlight which method I should use, I will always use oxidation number method. Here. It's simple and it's powerful. Are you hear that? Good. Now let's learn the last method today. Come on guys. Let's learn the last method today and we will kickstart with your application. So today's method is very, very technical. Today's method is very, very technical. You need some skill set. So I'll go very slow so that you can understand. Everyone, let's focus on here. Let's learn your last method for this particular subtopics. Okay, the last method we need to learn today is called electron method. The last method we will learn today is called electron method. Electron method is the most technical method among all. The most technical method, okay, and then the most popular question, okay, in your SEM. Okay, they love to ask you electron method. Among 4 methods, this is the most popular one in your paper. So listen carefully, guys. It is quite tedious. It is very, very tedious. You have many things you need to do. So please follow me. I go very slow on this. Okay, first and foremost, if you want to use electron method, you must have a thing like this. You must have a thing called half equation. Guys, what is half equation? Okay? If you still remember your Form 4 chapter 6, you saw this before, okay? Form 4 chapter 6, you saw a lot of half equation. In a chapter that you might not really like it, electrolysis, okay? In electrolysis, you will see a lot of half equation. We will revise that very soon, don't worry on that. Okay, that? Right now, guys, for those of you who have forgotten this already, or for those who never, gone through this with me, I want to help you to revise. A quick one here, guys. I'm not revising electrolysis. I just want you all to know this thing. Okay? In your chemistry learning, in your chemistry journey, you have total 3 equations. There are 3 types of equation. In chemistry, you have 3 types of equation. The first one called chemical equation. The second one called ionic equation. And the third one called half equation. So all of you must know what are the differences. What are the differences between chemical, ionic, and half equation? I will use one example for demonstration, and please don't memorize the example, it's unnecessary. So I show you an example. Magnesium plus copper sulfate becoming magnesium sulfate and copper. Magnesium plus copper 2 plus all the way become magnesium 2 plus and copper. Magnesium become Mg2 plus coupled with 2 electrons. Copper 2 plus coupled with 2 electrons, you become copper. Don't memorize any of the example here, okay? I hope after 5 minutes you can tell me the difference. That's good enough. Alright guys, you have 3 types of chemical equation. For now, no worry, you don't need to know how to write them. I'll teach you how to do later in a short while. I'll spend about 1 hour on this script, okay? For now, I just want you all to know, what is the differences between chemical, ionic, and half equation? When I gave you equation on the spot, you must be able to tell me that is chemical, ionic, or half. How you going to differentiate them? Quite easy. Chemical equation is the equation whereby the whole equation do not show us the charge. The whole equation, they don't show us the charge. All the charge are hidden like this. None of them, the charge can be displayed. Understand? So that is called chemical equation. Second one, ionic equation comes from the word ion. What is ion? You learn in Form 4, Chapter 2. Ion is anything got charge. Okay? So ionic equation is the equation that shows us the charge. Any equation that got charge is called ionic. Alright, then some people will say, sir, this fellow no charge, this fellow no charge. Okay? Ionic equation, you don't need everyone to have charge one. Example, if you have 4 fellow, for example, you have 4 fellows, only one fellow got charge is already ionic. Clear? You don't need to wait all the 4 fellows to have charge. It's okay one. Clear? As long as one of the fellow got charge, you already can call it as ionic equation. So far so good? Okay, next one. Half equation. Half equation always have charge, and you also come along with electron. Any equation that show you the charge, any equation show you the electron, that is called half equation. Got charge, got electron. Got charge, got electron. That's half. Are you hearing that? So when you are given the equation, you must be able to tell that is a chemical, ionic, or half. Okay? Right? So this is very, very important. Okay, now, what we're going to do next is this. For the next 30 to 40 minutes, I will try to teach you how to slowly convert this one all the way to this one. Okay, you will learn manually, step by step, how you convert a chemical equation all the way become ionic and half. Alright? This part a bit technical, it's quite tricky in a way, so I'll go very slow. Okay? I'll give you total 3 examples. If after 3 examples you still find it very blur, ask me. Okay? So let me show you how to do. Okay. So we must be able to do this. We must be able to convert your chemical. Guys, we must be able to convert your chemical equation all the way to ionic equation. After we convert to ionic equation, then we break down ionic equation to form 2 half equation. So these are the skills that we will try to pick up for the next 1 hour. Okay, we'll try to pick up this skill for the next 1 hour. This is one of the most important skills in this entire chapter. Alright, you might heard a lot in your school, YouTube, displacement, this and that. If you're not even able to catch up this concept, you cannot do. You cannot do at all. Alright, you must understand this concept. This is the most important concept in the whole chapter. Okay, so let's start. I'll go very, very slow. Okay, let's use first example for demonstration. Okay, let's use one example for demonstration. Let's say I use back this one. To be fair, I use back this example for demonstration. So first and foremost, I have a chemical equation. Everyone, I have a chemical equation on the whiteboard. I use back this example so you all can see how I do it. I have magnesium plus copper sulfate become magnesium sulfate and copper. Come, let's do this together with me. So this is a chemical equation. I frame it. Okay, now I want to teach you step number 1. Okay, step number 1. I want to teach you how to convert chemical to ionic first. How you convert chemical all the way to ionic. Let's do step number 1. So if you want to convert chemical equation all the way to ionic, you need to make sure you do 2 things only. Only 2 things you should do. 2 things. Number 1, you go to list out the charge. You list out the charge for every fella. You list out the charge for everyone. You list out the charge for every fella. Okay? Now you have to know who got charge, who don't have charge. Listen carefully. Okay? All substance got charge. All substance, they got charge except 2 fella. Number 1, if you are element. Guys, we learned from last week, guys. What is element? Anything made by one species. Anything made by one species called element, okay? Except element. Element got no charge. Second one, okay? The second one is called covalent compound. Covalent compound also got no charge. What is covalent compound? Covalent compound is something you learn in your Form 4 Chapter 5. Huh? Covalent and ionic. What is covalent if you forgot? Covalent is anything made by non-metal. So anything made by non-metal plus non-metal, that is called covalent compound. Okay, so that's it. So every further got charge except elements and covalent substance. No worry, we will use example for demonstration. Follow me. Guys, come on. I want you to participate on this. Okay, let's start with the first guy, magnesium. Okay guys, from your understanding, do you think magnesium got charge? Do you think magnesium got charge here? Yes or no? No. No. Alright, why? The magnesium here only got one species, right? Magnesium got one species, magnesium is element. Element no charge one. Okay, Alright, so no charge. No charge, just copy back. Yeah? Second one. Do you think copper got charge? Yes. What is the charge of copper? Cu? 2 plus. Very good. Okay? So, do we know the charge for sulfur? No. But do we know the charge for SO4? Yeah, 2 minus. So SO4, the whole thing is 2 minus. Very good. Okay? Now go to the right hand side, everyone. Right hand side. Magnesium, I know the charge is Mg, 2 plus. Right? Sulfate, I know is SO4, 2 minus. Copper is one species element, no charge. I feel that. So you're listing out all their charges. So far so good? Okay, next thing, what you can do now? Now you go to cancel out. You go to cancel out or you cut off the spectator ion. Guys, what it means by spectator ion? Spectator means audience, means the people who are watching. What it means by your audience? Okay, spectator ion are those ion that the charge remain unchanged. Any ion, the charge remains unchanged from the left to the right. When you go from left to the right hand side, the charge do not change at all. That fella is called spectator ion. Can we try to figure out what is it? Magnesium from no charge become got charge. There is a changes. Okay, so it's not spectator ion. Copper from 2 plus become no charge. Got change. It's not spectator ion. Sulfate from 2 minus become 2 minus is the same. So sulfate is a spectator ion. So you just need to cut it off. So you cut off the sulfate. Are you that? After cut off, you copy the whole thing, Mg. You copy the whole thing, Cu2 plus. You copy the whole thing, Mg2 plus. You copy the whole thing, Cu. So this particular equation is already your ionic equation. So you have successfully get your ionic equation. So far so good? Okay, not very hard. Don't memorize it. You learn the steps. Okay? Write a good balanced equation. List out the charge of every further in the equation. Compare left and right. Any further, the charge do not change at all. Cut it out. Okay? Then the remainder is ionic equation. So far so good? This is step number 1. Okay? You change chemical to ionic. Come, let's finish the rest. We have one more step here. Step number 2. Step number 2, your ionic equation now can be converted to 2-half equation. Guys, half equation forever got 2. It's not 3, it's not 1, it's not 4. Always got 2, okay? You always have 2-half equation. Why? Half plus half. 2-half equation combined, you get back 1 equation here. Clear? You always have 2-half equation, not 3 or not 1. Okay, now I teach you how to get half equation. Now, how to get half equation. This is step number 2. So now you will try to break the ionic equation. You will try to break the ionic equation all the way into 2-half equation. So ionic equation could be broken down into 2-half equation. Now guys, the big question to answer is how? How to break, okay? Listen carefully guys. How I break one ionic equation become 2-half equation. When you want to break, you use the concept I taught you previously. Apple to apple. Apple to apple. What do you mean by apple to apple? You break something with similar, what we call it, common, there are some common thing here. Okay, what is the first apple? For example, my first apple is magnesium, Mg. So I think magnesium should pair up with Mg2 plus. Because you can see they have something in common, isn't it? The second apple is Cu2 plus. Cu2 plus should be pairing with Cu. Can you see that? So now these one equation are broken down into two equations already. You got it? Alright? This fella and this fella paired up to be one equation. This fella and this fella paired up to be second equation. Okay? So now we have these two already. But we're not done yet because we know half equation is the equation that got charge, which we have it already. One more thing, what am I missing? Electron. Half equation must have charge and electron here. And how are we going to do it? If you are with me in Form 4, Chapter 4, we learned this before. If you are not, let's relearn again. Come on. Now, we know half equation must have electron. Okay. Half equation must have electron. So you only need to do two things here. Half equation always and forever got electron here. So you must know two things here. The first thing, how many electrons we need? Okay, how many electrons we need? Okay, by calculating the difference. By calculating the difference of the total charge. By calculating the difference of the total charge on both sides. Okay, by calculating the difference of the total charge, we were able to estimate the number or amount of electron. Okay, by looking at the difference of the charge, you were able to know how many electrons we need. Okay guys, let me show you something. I bring you up from here first. Let me show you some other thing, then we come back here. Let's say assume I have an equation. My left hand side, the total charge is positive 5. My right hand side, the total charge is positive 1. Positive 5 and positive 1 differ by 4. So in this particular case, since it's differ by 4, we need to use up to 4 electrons. Are you feel that? Same thing. If my total charge on the left hand side is negative 2, my total charge on the right hand side is 0. Negative 2 and 0 charge differ by 2, therefore 2 electrons is required. Understand? The differences of the total charge on the left and the right hand side will tell us how much electron we needed. Understand? Don't memorize. Clear? Alright. So second thing, after you found out how many electrons that you needed, you must know where to put those electrons. Okay? So at the end of the day, you always go to put the electron to the more positive side. Always put your electron all the way to the more positive side. Okay, now let us practice together. Come on, guys, let us practice together. Let's look at these two half equations. Okay, let's do it together. Magnesium on the left hand side, no charge. You can see nothing here. Magnesium 2 plus here. 0 and 2 plus charge differ by 2, right? So when the charge differ by 2, what is the information I know? I need 2 electrons. So the 2 electrons should put on where? The more positive side. 0 and 2 plus more positive. Therefore, I put the 2 electrons on the right hand side. Because the right hand side is more positive. Are you feel that? You do the same thing for the next one. This one I move a bit on the right so that you can see better. Else it's a bit confusing. Sorry for that. Okay guys, let's do this. Cu2 plus, the charge is 2 plus. Cu no charge, charge differ by 2. Therefore, 2 electron is needed. Electron must put on the more positive side. 2 plus is more positive than 0. Therefore, I put my 2 electron on the left. Are you feel that? Alright, so now we frame the whole thing together here. In exam, you don't need to frame, I just show you only. Guys, can you see that just now, we might don't know how to get this. Now you can clearly see how everything is operated. You got me? Alright? So, step by step, okay? When you given a chemical equation, you list out all the charges on the left and the right hand side. We're comparing left and right hand side. If there is any charges, do not have any change, you cut it out. So after you cut out, you get ionic equation. The ionic equation can be broken down to form two half equations. Understand? How you break it down? You break according to the apple. Understand? Anything similar, you group them together. Like Mg, go along with Mg2 plus. Cu2 plus go along with Cu. And we know half equation must always come along with electron. There's only two questions to be addressed. Number one, how much electron we needed? Number two, where to put those electrons. Clear? That's it. Not very hard. You got me? This is the most technical thing in this chapter and you must make sure you know. So far so good. Okay? You jot down on this, we'll do two more special cases together. Then I'll let you do some exercise on your own. Okay? Alright guys, let's do two more examples, then you can do some self-test for me. Yeah? Okay, this is the first one, alright? So I hope you can get some idea first. We will do two more examples. Hopefully, you have a much better idea for the next two examples. Okay, come. Let's try to do the second example together to get the idea. So now let's go for the second example. For the second example, let's assume that we have a chemical equation. Let's say I gave you a chemical equation, zinc reacted with nitric acid to form zinc nitrate coupled with hydrogen. Let's say, don't memorize. Let's say this equation I've given to you. Okay, first of all, guys, you don't rush to do all the things here. Whenever you're given chemical equation, you have to make sure it's balanced first. Understand? Alright? You must make sure your equation is balanced, then only you carry out all the tasks over here. So let's balance it. Let's put a 2 here, and your chemical equation now is balanced. So now we already have a balanced chemical equation. As usual, step number 1, we want to change the chemical equation become ionic. How we do that? We list out all the charge. Zinc is a one species element, no charge. The N. Hydrogen, everyone know hydrogen is H+, you should know that. And watch out. How many hydrogen we have? 2, correct? You have 2 hydrogen here, so put a 2 here, please. Same thing. Do we know the charge for nitrogen? No. But do we know the charge for the whole NO3? Yeah. The whole NO3 is nitrate. Nitrate charge is NO3, -1, not 3 negative. Okay? So how many nitrate we have? 2. Because remember, all the number in front is given to everything at the back. So the 2 here belongs to the H, belongs to the NO3. So you have 2 of it. Understand? Okay, settle left hand side. Right hand side. What is the charge for zinc? Zn 2+. Okay, next one. What is the charge for the NO3? The whole NO3 is nitrate. NO3, -1. How many nitrate we have? 2, correct? You have 2 nitrate. So guys, watch out. If the number is at the back, the number only belongs to the nearest fella. If the number 2 is in front, the number belongs to everything at the back. Okay, Okay, settle. Now what about this fella? Hydrogen. This hydrogen only got one species. It is element, no charge. So no charges copy. Are you hear that? Alright, now as usual guys, compare left and the right hand side, go to find the spectator ion. Spectator ion is any fella, the charge doesn't change. In this case, who is it? Nitrate, right? Nitrate, the charge doesn't change. Cut it off, okay? So after cut off, copy again. Zn plus 2H plus all the way, Zn2 plus H2. So this particular equation is our ionic. So you already get your ionic equation, okay? But we don't stop here because our ultimate objective is half equation. Here, how we do that? So if you want to do half equation, how many half equation we have? 2. We always have 2 half equation. So we must group them accordingly. First of all, I take the zinc pairing with zinc 2+. So zinc pair up with zinc 2+. Second one, my 2H plus would pair up with H2. Okay? Now let's do something as usual. I am in the midst of preparing a half equation, and I know half equation got electron, correct? The electron is decided by the charge. Left hand side no charge, right hand side 2+, the charge differ by 2 electron. Electron must be placed on the more positive side. So I put on the right. So far so good? So I already created my half equation. This is my half equation, number 1. I have the first half equation already. Second thing, let's do here. Guys, what is the total charge on the left hand side? Positive. How much? 2, not 1. Total charge. Total. H plus is positive 1, but you got 2 of it. You must times 2, okay? Total charge. Total charge on the left is plus 2. Total charge on the right is 0. Plus 2 and 0 charge differ by 2. 2 electron is needed. Electron put on the more positive left hand side. Are you with that? It's not hard, but watch out this. Total. Are you with that? Alright, so it cannot be plus 1, it's plus 2. So if you make the mistake here, the whole thing wrong. Okay? Please be careful. Alright, so now this is the second half equation. So we have successfully converted the chemical equation become the half equation. Understand? Not very hard, it's just tedious. Many things to do. But if you do step by step, you'll be fine. Are you okay with that? You like it or not, you need to know this because this is the most important thing in this whole chapter. So far so good? Okay, let's do the third example. Let's do the third example together. Then I let you do some self test for me. Okay, come. Let's do the example. Let's put here. This is example number 3. Let's do this. This is the last example I'll discuss with you guys before you do some self test for me. Okay. So as usual, I give you a chemical equation in the first place. Let me give you a chemical equation first. Okay. Let's say, assuming that I have a calcium. Yeah, assume I have calcium. Then I have a silver nitrate. And I produces calcium nitrate all along with a silver. Okay, this is a chemical equation. I don't see any charge at all. So far so good. Guys, before I start to do whatever thing, what should I do? Balance the equation here. Some of you just rushing, directly go on, and in the end, everything wrong just because you didn't balance. Are you with that? You must balance the equation before you start with whatever thing. Come, let's balance it up. So I do faster. Let's put a 2 here. Let's put a 2 here. I think everyone know how to balance. Assume that. Alright? So this is a chemical equation. Okay, now I want to convert my chemical equation to become ionic in the first place. So to do that, first and foremost, we list out all the charges. Okay, on the left hand side, what is the charge for calcium? Calcium is one species, so it's element, no charge, Ca. On the left hand side, the silver is Ag plus, everyone should know. How many silver we have? 2, so times 2. On the left hand side, we also have nitrate, NO3 minus. How many nitrate we have on the left, everyone? 2. So far so good. Everyone know where the 2 coming from? Very good. Go to the right hand side, please. Right hand side we have calcium, the charge is Ca, 2 plus. On the right hand side we have nitrate, NO3 minus. Guys, how many pieces of nitrate we have? 2, alright? Because you have a bracket and 2. Very good. Last thing, the 2 silver here, make a guess, what is the charge? 0, no charge because you have one species element. Remember, element, no charge at all. Clear? Okay, now, comparing left and right hand side, do you know who to cut? Nitrate, right? Because the nitrate doesn't change, okay? You cut any further, the charge doesn't change. Nitrate doesn't change. Cut it off. So after cut off this remainder, copy again. Calcium 2 plus, 2Ag plus, become calcium 2 plus and 2Ag. So this fella is my ionic equation. Make sense? Ionic equation got charge but no electrons. Lastly, I can break the ionic equation to 2 half equation. Always 2. Okay, now let's do the 2 half equation. Let's do your apple and apple pairing. The first one, calcium. Sorry, this is calcium only. I read wrongly. Shouldn't have charge here. My bad. Okay? Shouldn't have charge here. This element no charge. My bad. Okay? Now, let's do pairing. Calcium should convert it to calcium 2 plus. That's the first thing. Second one, 2 silver ion is converting to become 2 silver. Okay? Let's do as usual. Calcium, no charge. Calcium 2 plus, plus 2. 0 and plus 2 charge differ by 2. Put the 2 electron in on the more positive side. So this is my first half equation. I don't think it's very hard. Okay? Now guys, I want all of you to watch out here. Watch out this one, Watch out this one. Here, this is where a lot of you will do mistakes, and it's not your problem because you get used to a format. Look at here. This part not hard, but a lot of you will do mistakes. Okay, I will tell you what might be the mistake that you do. Okay, you will say this. Okay, I got silver. Okay, so The total charge on the left hand side is positive 1 times 2, so it's positive 2. Right hand side here, nothing, no charge. Positive 2 and 0, no charge. Sorry, positive 2 and 0 charge differ by 2. We need 2 electrons. 2 electrons put on the more positive left hand side. This is what most of you will do. Clear? But it's wrong. Okay? Why it's wrong? It's not your problem. You have to be very, very careful with this. Okay, listen carefully. Let me bring you to a simple mathematic concept. Then only we come back to this. Guys, when you do mathematic, normal linear equation or even normal algebra, what you can do, you see, today if you have 2x equivalent to, let's say, 2y, mathematics you all should know, when the number in front is the same, you can cut off. Am I right? Mathematics, true or not? You can cut off, right? Okay, even the number in front not the same. For example, this is 2x and this is 8y. You all should know all the number in front could be simplified. Am I right? 2 and 8 you can cut off here. This one become 4. Am I right? That's mathematics, right? You can apply the same concept over here. Guys, how? Come back to here, please. Erase and look at here. Do you realize that the silver, the number in front is 2? And this silver, the number in front also 2. Are you glad? When the number in front can always be simplified. Are you glad? The number in front always can be simplified. The number in front is 2. The number in front is 2. You must simplify. How you do that? You cancel out the number here. Understand? If you don't cancel, wrong. Are you glad? So whenever you get your half equation, the number in front could be simplified, you must simplify. Are you okay with that? Here, come, let's do as usual. Now after I simplify, let's do as usual. Total charge on the left, positive 1. Total charge on the right, 0. Positive 1 and 0 charge differ by 1. 1 electron put on more positive side. Understand? Here. So this is what you need to know. So it's not your problem, but a lot of people will forget to simplify the number in front. Get it? So whenever the number in front can be simplified, you must simplify. Understand? It's a must. It's a must. So now you get your half equation number 2. Okay guys, before we take a break on this, after 3 examples, you can see what is happening. Alright? Not very hard, right? But it's very tedious. True or not? You need to do so many things. Imagine the one we learned 2 weeks ago, oxygen method. Do nothing, just choose the apple and compare, that's all. Hydrogen method, just choose the apple and see who gain, who lose, hydrogen settle. Oxidation number, a little bit troublesome, but not hard also, true or not? Just list out all the number and choose the apple, settle. But this one's so tedious. You have to do so many things. Are you okay with that? Alright? But this is one of the most important methods. So far so good? Alright guys, take your time to jot down on this, and I will put on 3 exercises on the whiteboard as a self-test, and I want you to do the self-test. Okay, I want you to try to do the self-test for me. Okay? You jot down this, and you try to do these 3 self-tests for me. We will discuss in the classroom after 10 minutes. Yeah? Take your time to jot down these two examples on the whiteboard. I give you 10 minutes to try these 3 questions on your own. Okay? You should do what I did. You should tell me, you should give me 1 ionic equation and 2 half equation for each. For each of them, I want to see 1 ionic equation and 2 half equations. Okay, take your time. Right guys, I hope you have tried out these 3 questions. Let's see how are we going to do it. Okay, so remember guys, you can see I put a reminder over there. For all the questions here, you should balance them first before you even kickstart with your conversion. Okay, the first one, K plus HCl become KCl and H2. So you do your balancing thing. Again, I don't want to go in detail. You can put 2 here, you can put 2 here, you can put 2 here. Okay? So this is how you balance the equation. So this is your chemical equation. After that, you list out the charge. Potassium is 1 species element, no charge. Hydrogen is H plus, and you have 2 of it, put 2. Chloride is Cl minus, you have 2 of it. After that, potassium is K plus, you have 2 of it. Chloride is Cl minus, you have 2 of it. Hydrogen is 1 species element, no charge. Compare among the left and the right. You will realize that the chloride, the charge doesn't change. Chloride is a spectator ion. Cut it out. So after cut out, you copy again. 2K, 2H plus, 2K plus H2. So this is your ionic equation. Ionic equation don't need to simplify one. The simplification, the one we learned, only works for half. Okay? Ionic equation no need to simplify. Just cut out spectator ion and copy it. That's it. Clear? So you got your ionic equation. Now let's break it down into 2 half equation. Half equation number 1. 2K go along with 2K plus. Second half equation, 2H plus go along with H2. Okay guys, the first question, 2K and 2K plus. For this one, can we simplify? I think so, right? The number in front is 2. The number in front is 2. The number in front could be simplified. Cut it off. Okay? So now you have K become K plus. K become K plus, charge differ by 1. You put 1 electron on the more positive right hand side. And this is your first half equation. So far so good. Second one, 2H plus and H2. Can we simplify? Cannot. The 2 is in front here. This further no number in front is 1. 2 and 1 cannot simplify. Then some people might say, sir, this is 2. This is 2. Cannot. This number 2 is in front. This number 2 is the back. Cannot. You only can simplify the number at the front. Here. So you cannot simplify. Directly proceed. Total charge on the left, positive 2. Total charge. Total charge on the right, 0. Positive 2 and 0 charge differ by 2. Put 2 electrons on the more positive side. And here we are, the second half equation. Are you okay with that? So this is your answer. Chemical ionic half equation. Okay? Settled. Second one is this. Magnesium plus oxygen become magnesium oxide. So balance it first. Put a 2 here, put a 2 here. So you have a balanced chemical equation. Now, you list out the charge. Magnesium is element, no charge. Oxygen is 1 species element, no charge. Magnesium is Mg2 plus. How many magnesium we have? 2. Oxygen, the charge is O2 minus. The number is 2. So far so good? This is a very, very special case. If you realize nothing to cut, true or not? So a lot of people, when they saw this question, they feel very skeptical. They say, how come nothing to cut one is possible? It's possible. Clear? Some people keep searching for something to cut. Not necessary. Okay, this question, no nothing to cut. So this fella, even without cutting, is already the ionic equation that we want. Okay, nothing can be cut. So far so good? Okay, now let's do as usual. Split into half equation. 2 magnesium becoming 2 Mg2 plus. O2 become 2 O2 minus. Now, for this half equation, can we simplify? Yes. There is a number 2 in front here. There's a number 2 in front here. We can simplify. So cut off the 2. So magnesium become magnesium 2 plus. The charge differ by 2. Put 2 electrons on the more positive right hand side. End of story. What about this? Can we simplify this one? No. The number in front here, no number means 1. The number here is 2. 1 and 2 couldn't be simplified anymore. Yeah? So directly proceed. What is the total charge on the left? 0. What is the total charge on the right? Negative 4. Total, huh? Negative 4. 0 and negative 4 charge differ by 4. 4 electrons needed to put on the more positive left hand side. So this is how we get it. So far so good? Alright? Not very hard, but you must understand the logic behind. So far okay? And never try to memorize the equation. You are not going to make it. Even you can prove to me you can, no use. Here, if the question change, you cannot do one. So far so good? So you must learn the logic behind, because they can twist and turn the question. Okay? So anyone need my further explanation or for me to further elaborate on 1 and 2? Okay, so far? Good. Let's go on with number 3. So the third equation is this. Okay, let's look at the third one, everyone. Look at here. Zinc react with silver nitrate, becoming a zinc nitrate along with a silver. Same thing, balance the equation first. A 2 here and a 2 here. So by putting a 2, now you have your balanced chemical equation. Okay? Now, as usual, write out the charge first. Zinc is one species element, no charge. Silver is Ag plus. You have 2 P's times 2. Nitrate, that is NO3 minus. You have 2 P's times 2. Zinc is the N2 plus. Nitrate is NO3 minus. There are 2 nitrate in the first place times 2. Silver is one species element, no charge. Just copy the whole thing without charge. Compare left and right hand side, the nitrate doesn't change. Cut it out. After cut, copy again. Zinc plus 2Ag plus all the way become zinc 2 plus and 2Ag. So you have obtained your ionic equation. At the end of the day, split into 2 half equation. Zinc become zinc 2 plus, that's the first one. 2Ag plus become 2Ag. That was the second one. This one cannot be simplified already. The charge different by 2 on left and right. 2 electron put on the more positive right hand side. For this one, we can simplify. Number 2 in front can be simplified, cancel out. After cancel out, the silver here is plus 1. The silver here is 0. Plus 1 and 0 charge differ by 1. 1 electron on the more positive side. And that's how we get it. Okay? So make sure you know this. This is one of the most important skills you must know, alright, in this chapter. Because in this chapter, no matter you learn in your school, YouTube, Fe2 plus, Fe3 plus, metal displacement, halide displacement, if you go and check, it's all half equation. There are so many half equations in this chapter, and a lot of you will go to memorize the half equation, which is bad. Don't do that. Okay? You must learn how to get the half equation, and it's doable if you know this skill. Okay? Settle. Okay, now, Give me another 5 more minutes. I'll do the final closing of this. Then we will move on to the application. We will learn how to apply your redox, such as rusting blah blah blah. That one later. So now, okay. So for now, we have learned a very important skill today. We have learned how to change chemical, become ionic, and half equation. Alright guys, why we do so many things? Why we do all these things? Because it all go back to the ultimate objective for today's lesson. If you all remember guys just now, what is the main intention when we first started with today's lesson? We want to use electron method to do your apple to apple comparison. Am I right? Okay? So guys, why you learn all the things here? The reason is this. Whenever you all want to use electron method, whenever you want to use electron method for the apple to apple comparison, you must have half equation. Why? Why we must have half equation? Then only we can use electron method. Very simple. Let's use this example for demonstration. Listen, listen carefully. Guys, if I give you chemical equation, if I gave you this first equation, the chemical equation, do you think from this equation on a quick glance, can you tell me who donate, who receive electron? Can you tell me? Okay, some of you might be able, but most of you cannot. You got it? Why? You can't even see electron in the first equation, true or not? The whole equation, you don't see electron at all. You can't even see the electron. How on earth you know who donate, who receive? Understand? Same thing. If I gave you or you work on yourself, you get your ionic equation, still cannot. Because even you have ionic equation, you still cannot see any electron on it. So if you cannot see the electron, you won't know who donate, who receive electron. Clear? But what if we have half equation? Yeah, when you have half equation, you can clearly see those electrons. Understand? At least now you can see the electron. So when you can see the electron, now you can decide whether you are donating or receiving electron. Can you see that? So everything we learn is because we want the half equation, because the half equation shows us the electron. Because when you see the electron, then only you can use electron method. Does it make sense? Yeah. So now, let me teach you how to interpret half equation, guys. How are we going to interpret or analyze? How are we going to interpret or how are we going to analyze the half equation? Shh. This is important. Listen carefully. Alright. When you want to interpret half equation, guys, when you want to interpret half equation, you must be very careful with this. Okay? So this is a side notes. Okay? Location of electrons, very important. Locations of electron, very important. You have to be careful with the location of electron, left or right. Okay, listen. If the electron is found on the left, if the electron found on the left, which means that you are receiving the electron. Okay? If the electron is found on the right hand side, which means that you are donating the electron. You are donating the electron. That's it. Location of electron will tell you whether you are donating or receiving the electron. Are you okay with that? The problem is this. Sometimes, as a student, you know donate, you know receive, but in exam, you forgot. You forgot. So you forgot who is donate, who is receive. Okay? And you confuse yourself. So how are we going to recall back or we use the proper way to predict or estimate? Again, guys, listen carefully. I show you a way how I used to memorize last time. Okay? Same thing. It go back to what I like to say, common sense. Okay? How to use common sense? Look at here. How to use common sense on the location of electron? Look at here. Okay, imagine, guys. Imagine. Okay. How to know you are donating or receiving electron? We use this equation for demonstration. Zinc become zinc 2 plus and 2e. Okay? Imagine zinc is a human. And the electron is found on the right hand side. So when the electron found on the right hand side means what? This is zinc, I am zinc. Why electron go to right hand side? Because the zinc throw the electron. No, not. The zinc throw the electron. Because I throw, it go there. So the electron is here. So when I throw the electron, what happened? Donate. Make sense, ma? When the electron far away from me, means what? I throw away. I throw away. Alright? Now, vice versa. What about the second fella? What about that? Today, if you have a silver ion plus electron becomes silver, what about this? Today, this is silver. This silver is the stickman. So this is the electron. So now the electron so close to silver, right? When the electron very close to me, what happened? You can take it. True or not? When the electron so close to you, you can take it. Take it means what? Receive. Are you okay with that? So this is what we call common sense. Here. So if you see the electron on the right, the electron far away from you. Why electron go so far? I throw one. I throw the electron, that's why far. Donates. When you see electron on the left hand side, electron very close to me, I can take it. So receive. Clear? This thing will help you if in exam you're panicking, you forgot, you can use this. Okay? Some of you guys, you understand, you know what happened, but when you go in exam, you always underperform one. Okay? Because you panic. Okay? Alright, so this is the one. Okay? So one of the way, I hope this one can help you a bit here and there. Okay? Common sense, huh? Okay, now. Okay guys, shh. How are we going to do apple to apple comparison? Okay, how do we do apple to apple comparison using electron method? Okay, everyone can flip back to the first page of the notes when we first started 3 weeks ago. You can see this, everyone can flip back? Okay, oxidation and reduction can be decided by 4 different methods if you remember. The first method is oxygen method. The second method, oxidation number method. The third method, hydrogen method. The last method, electron method. If you remember, I say how to memorize. Look at the first letter. O and O put plus. O and O put plus. O and H, different letter, put minus. O and E, different letter, put minus. Everything here opposite. Are you with that? Okay guys, why I want to show you this? I am trying to teach you electron method, okay? So let's focus on electron method here. So when we want to do electron method, can we do together on this? Okay, now everyone click on here, look at here. Let's do electron methods. In this particular case, I saw the electron far off, go away. So which means I donate or receive electron? Donate. Who donate? This fella, right? This fella. What is the name of this fella? This fella is called zinc. So zinc got charge or not? No charge. So when zinc got no charge, you always add the word atom. Understand? If the zinc got charge, what is the name? Zinc ion. Clear? Alright? If you have no charge, I call you atom. If you got charge, I call you ion. Clear? So zinc atom, this fella will donate. So if I don't want to use donate, what I can write? You can write lose. You also can write release. Okay? So guys, the zinc atom here donate how many? 2. So you donate 2 electrons. Okay? From electron standpoint, from electron perspective, when you donate, when you lose the electron, that is oxidation, right? When you lose electron, that is oxidation. Zinc atom lose the electron. Therefore, zinc atom is undergoing oxidation process, is oxidized. So far so good? As usual, when zinc undergo oxidation, you know what happened, right? Zinc is reducing agent. So zinc atom automatically serves as reducing agent. Okay? Now can we try this fella? Second fella? Okay, now from this picture, electron found on the left, which means receive, right? Who is the recipient? Ag plus. Guys, how I write the name of Ag plus? Ag plus. When this fella got charged, the name must automatically add a word ion. Clear? You forgot this word nomad, they are very strict on that. They are very particular. So silver ion receiving. If you don't want to write the word receive, no problem. You can write something the same meaning, gain. You also can write the word accept. All these words are acceptable. Okay that? Alright, silver ion receive or gain or accept. How many? 1. Alright, you accept 1 electron. Everyone, from electron perspective, when I receiving electron, the process is reduction, right? Silver ion undergoes reduction. When silver ion undergo reduction, silver ion automatically oxidizing agent. I hope all these things make sense to you. Are you with that? We have finished all 4 methods. So if you realize among 4 methods, which one is the hardest one? Not to say hard, guys, yes. Because you have to do so many things. Understand? And do you understand why we need to do so many things? Because if you never convert chemical to half equation, you cannot see the electron yourself. If you cannot see the electron, how on earth you can use electron method? Here, you can't even see the electron. How you want to use electron method? Okay? So we learned about 1 hour plus, just prepare us for this. Okay? Alright? So that's why this method they always ask you, because they know some of you get stuck in this. So far so good? Alright, any question? Okay, so I'll give you some time to jot down in a short while. Now give me some time, I go on a little bit more. Let me touch one more concept, then we stop in today's class. Okay? Now, this one you done already, right? Okay, so just erase. This one I keep. Okay, so you see guys, we purposely spend 2.5 hours, sorry, we spend more than that. We spend about 5 to 6 hours just to teach you all the methods, the 3 methods, sorry, 4 methods, because these methods are very, very important, okay? So guys, a quick summary before you go on, a quick summary. Okay, we have total 4 methods for us to determine oxidation or reduction. You have 4 methods for you to decide the process. It is oxidation or it is reduction. Okay, come on, let's link the method together. Oxidation method, hydrogen method, oxidation number method, and electron method. The most important one is oxidation number and electron method, which are the 2 harder ones. Here, guys, trust me lah, they won't ask you oxygen method, that's kindergarten. Here, everyone can do it. They won't ask you hydrogen method, too simple. Okay? So you all must know oxidation number method and also electron method. You must know oxidation number method, you must know electron methods. They are very important. Okay, now we have finished all the important theory. I have taught you all the necessary fundamental. Guys, if you all recap, we have learned 4 methods, although it takes some time. I hope you learned something. But if you really think back, no matter what method you use, the recipe is the same. What is the recipe? Apple to apple comparison. What is the recipe? Answer that 4 questions. Who oxidizes? Who reduces? Who is oxidizing agent? Who is reducing agent? Understand? The whole thing is about that 4. Are you clear with that? Yeah? Alright, now I will show you the next thing called application. What is the application of redox? Where and how you apply the redox in your chemistry? Number 1, the first application is something I'll teach you in a short while called metal displacement. I'll teach you this in a short while. The second one called halide displacement. I'll teach you this by next week. The third one is actually called Fe2 plus convert to Fe3 plus, Fe3 plus convert back to Fe2 plus. The next thing you will learn is called U-tube. A tube in a U shape, U-tube. After that, you will learn something called rusting. Lastly, you will learn something called reactivity series. Okay? So some of you, your midterm will cover until here. Some of you, your midterm will cover until here. If that is the case, you can get some extra video from me. Understand? From last year one, you can watch it at once. Okay? Right. So now, we will learn the first thing today. Okay? We will learn this first one. The first thing. The first thing you will learn today is called metal displacement. Let me give you a very quick concept and a shout out on the metal displacement for 5 minutes. Then you can jot down the rest. Okay? First and foremost, you must know what is metal displacement. And you must understand this, because if you understand this, you will understand this thing easily. They are like siblings, they are like twins. Okay? First and foremost, you must understand what it means by displacement. From now onward, whenever you saw the word displacement, it's all about this concept. I call it gangster, bully concept. I call it gangster, bully concept. Whenever you saw the word displacement, it's all about gangster, bully concept. What is gangster, bully concept? The more powerful gangster, will go to rob or will take away the belongings. The more powerful gangster will rob or take away the belongings of the less powerful one. Okay? So imagine there are two gangsters fighting each another. So the more powerful gangster is a winner. The winner takes it all. It takes all the belongings of the less powerful one. Are you okay with that? Yeah. Okay, now you must understand two concepts. Number one, how on earth we know who are those gangsters? Who are those gangsters? Those gangsters are metal. Metal displacement. The gangster is metal. Okay? So all the metal here are those gangsters. Now, when we have so many metal, how on earth we know which metal is a powerful gangster, which metal is not? Alright? You learned already in your Form 4, Chapter 6 last year. ECS. ECS. I hope you still remember what is ECS. Because as a science, as a chemistry student, if you don't know ECS, something wrong. Alright? Let's look at it. Okay. ECS. ECS is your electrochemical series. Electrochemical series, okay, is your E, C, and S. Okay? The electrochemical series is ECS. Guys, how many of you here, up to now, you still cannot memorize ECS one? How many of you? Okay, stop, okay? Alright, just be frank with me, I'm okay one, alright? I'm here to help you, okay, come. Alright guys, if you cannot memorize ECS, let me show you. If you are with me last year, you should know the table, kalau, nakawin, the thing, okay? If you never see that, let me show you. Okay, let me show you what, if you never see that. You can use any way to memorize, no problem, okay? My way is this. So this is my version, okay? Kalau nak kahwin mesti ada zakat, fantastic. Sebab bapa hendak cucu anak. You can use your own version, no problem. Kalau is K+, Nat is Na, sodium. Kahwin is calcium, Ka. M is magnesium. A is aluminium. Z is zinc. F is iron. S is Sn, tin. P is Pb, lead. H is hydrogen. Cu is copper. A is silver. You know until silver will do. Even though some of the school teach you until gold, the oral, you don't need to know until gold. You know until silver is more than enough for SPM. Can you hear that? Shh. So this is your ECS that you should heard about it, you should know about it since your Form 4 Chapter 6. But it's not too late to know by now. Hey guys, shh. This is a table show you the ranking of gangster. The higher metal on top, you are a more powerful gangster. The higher you are, if you are more powerful gangster. Guys, which is normal, you can see. When you go for those hierarchy, the higher the ranking, of course you are more and more powerful. Okay, that you never see that. Oh, this is actually okay. This one show you the gangster one. The most powerful taiko will be the last one. No, normally the last one is the weak one. The top ranking one is the powerful one. Okay, that. Okay, so this is your ECS. The higher metal in ECS, they are more powerful gangster. Okay, so what is the advantage for being a more powerful gangster? Look at here, they can rob the belongings of less powerful. Okay, let me show you 3 examples, then we stop. Okay, 2 to 3 examples, then we stop on this. Okay, the first one, look at here. I have a magnesium go along with copper sulfate. Everyone, eyes on here. I have magnesium react with copper sulfate. Okay, shh. Magnesium is somewhere here. Copper is somewhere here. So everyone can see magnesium is higher than copper. In the other words, magnesium is a more powerful gangster than the copper. So what magnesium can capable to do? Magnesium can rob the belongings of the copper. Who is the belonging of copper? Sulfate. So when magnesium take off the sulfate, so now the sulfate will go with the magnesium because it's taken by the magnesium already. When the sulfate taken by the magnesium, the copper got nothing left. So the copper now become alone. Understand? This concept called metal displacement. A more powerful metal rob the belongings of a less powerful metal. Are you okay with that? It's not hard, right? Okay? So guys, shh, listen carefully. What if we change the question like this? What if, okay, what if now the copper want to revenge? What if the copper want to revenge? Copper wanted to rob the sulfate from the magnesium. So copper and magnesium, copper is here, magnesium is here. Copper is lower than magnesium in ECS. Copper is a less powerful gangster. Will copper be able to rob? No. So what will happen? Nothing. So in this case, no reaction. Nothing will happen. Are you okay with this? This particular concept is called metal displacement. Understand? More powerful metal kick out or rob the less powerful one. Clear? Okay. Show you one last example. One last example. Okay. One last example here. So, what if we have a sodium go along with copper sulfate? Now, this last example is good. Guys, the concept not hard, but a lot of people they take it too easy. I repeat, the concept is not hard, but many people take it too easy. What happened here? Okay, I asked a few questions to you all. Okay, now, who are the gangster fighting now? Number 1 is sodium. Second gangster is copper. Okay, as you all can see, sodium higher than copper in the gangster list is yes. Okay? So sodium is the more powerful gangster than the copper. Technically, sodium can rob the sulfate. Very good. So when sodium rob the sulfate, the problem for many of you is what? You take it easy. Is it easy lah? Sodium, sulfate just stick along. And then copper become alone. This is what most of you will do. Wrong. Okay? So guys, what goes wrong? Since you say it's wrong, very true. 1. The SO4, the charge thingy. Very good, guys. Look at here. Many people, they take it easy. They know sodium can rob the sulfate. They just simply take the sulfate and stick along with sodium. No, you cannot do that. Listen carefully. Sodium memang will combine with the sulfate. Yes. Sodium combined with sulfate, you will get sodium sulfate. But what is the formula for sodium sulfate? What is it? You learn this in your Form 4 Chapter 3. Form 4 Chapter 3. When you want to know the formula of a furler, you can predict the formula. Guys, I know when sodium merge with sulfate, I get sodium sulfate. What is the formula? Sodium, the charge is Na plus. Sulfate, the charge is SO4, 2 minus. When Na plus and SO4 2 minus merge together, Form 4 Chapter 3. When the charge is different, what do you do? Cross. So the 2 come to the left, the 1 go to the right. Na got 2. Na 2. SO4 got 1. Can you see the 2 make a big difference here? Are you okay with that? So you cannot simply, oh, this is more power gangster, I just stick together. Don't do that. You must know a proper formula. Okay? So please be very careful. Okay, we have finished the metal displacement concept. Are you okay with that? Not very hard, okay? So the whole thing here looks like, oh, so many things, but they're not hard. Because you all have all the basics already, the rest will be easy. Here, in next lesson, we will do more and more exercises on metal displacement. For today, you just need to make sure you know what is metal displacement. A more powerful metal rock the less powerful metal. Here, how to know who or less powerful? ECS. Yeah, that's it. Jot down this and we finish with today's class. That's all. Yeah.